Hello, my dear students and the rest of the learners. Welcome to part 21 of the 7-part series of tutorials in computer structured programming unit using C and Pascal. This is section 4 of 4 in the topic subprograms. My name is MemJM, or you can simply call me EMELISWAP. In this tutorial, I'm going to look at recursion. I'll focus on the meaning and importance of recursion in programming. And then we are going to look at an example of recursion by calculating the factorial of a number in C and Pascal, and also determining the end value in a Fibonacci series in C and Pascal. What is recursion? This is a process in which a subprogram calls itself either directly or indirectly through another program. So the self-invocation could either be direct or indirect. Direct invocation means that the body of the subprogram contains a reference to itself. Indirect invocation means that the subprogram calls another subprogram, which in turn calls the first one. Recursive problem-solving approaches have a number of elements in common. A recursive subprogram is called to solve a problem. The subprogram actually knows how to solve only the simplest case or cases. So, recursion is a powerful technique in which some problems can be expressed in a form which is very close to their natural statement. Recursive functions have a basis part, a recursive part, and a termination condition. The termination condition is very important to ensure that the repeated self-invocation comes to a halt at some point. If the termination condition is not provided, or if it is incorrect, then an infinite loop can result. If a subprogram is called with a base case, the subprogram simply returns a result. If the subprogram is called with a more complex problem, then the subprogram divides the problem into two conceptual pieces, a piece that the subprogram knows how to do, and a piece that it does not know how to do. To make a recursive feasible, the latter piece must resemble the original problem, but be a slightly simpler or a slightly smaller version. Because this new problem looks like the original problem, the subprogram launches or calls a fresh copy of itself to go to work on the smaller problems. This is referred to as a recursive call and is also called the recursion step. The recursion step also includes the keyword return in C because its results will be combined with a portion of the problem the subprogram knew how to solve to form a result that will be passed back to the original caller, simply the main or possibly the main. The recursion step executes while the original call to the subprogram is still open, that is, it has not yet finished executing. The recursion step can result in many more such recursive calls as the subprogram keeps dividing each problem it's called with into two conceptual pieces. In order for the recursion to terminate, each time the subprogram calls itself with a slightly simpler version of the original problem, this sequence of smaller problems must eventually converge on the base case. At that point, the subprogram recognizes the base case, returns a result to the previous copy of the subprogram, and a sequence of returns ensues all the way up the line until the original call of the function eventually returns the final result to the main. The following are examples of two programs that implement recursion. One, to calculate the factorial of a number, and two, to determine the end value in a Fibonacci series. We begin with calculating the function of a number. We begin with calculating the function of a number. We begin with calculating the function of a number. That is the function called Factorio. So, how do we calculate factorial of a number? Factorial of a number, which we write mathematically as n exclamation mark, simply means that you multiply all the whole numbers from your chosen number down to 1. That is, n factorial is equals to n times n minus 1 factorial. This means that n factorial is equals to n times n minus 1 times n minus 2 times n minus 3 times n minus 4 all the way to the lowest number, which is times 1. This means that factorial of any number is that number times the factorial of that number minus 1. Therefore, because to get factorial of any number, you multiply that number by the factorial of that number minus 1, then factorial is said to be a recursive function. For example, if you want to compute the factorial of 4, it is simply 4 times 4 minus 1 factorial. That is 4 times 3 factorial. But what is 3 factorial? 3 factorial is the same as saying 3 times 2 factorial. But what is 2 factorial? 2 factorial is the same as saying 2 times 1 factorial. And therefore, 4 factorial is simply saying it is 4 times 3 times 2 times 1, giving 24. So that's what factorial is all about. So how do we implement that in C? So the following is a sample program in C for calculating the factorial of a number using recursive function called Factorio. So that is the comment. Calculating factorial of a number using a recursive function called Factorio. That's our preprocessor directive for allowing us to make use of the input and the output devices. And then at this point, we are defining a function for computing factorials. Our function is called long. This function is supposed to return a value to the main function or the caller, and that value is supposed to be of type long. And it is receiving a value. It is receiving one parameter, and that parameter is num. So whatever value that it is going to receive, that value, which is of type long, will be stored in the memory location temporarily, which we are calling num. So num is a local variable to the function called Factorio. So it is a formal parameter. It is a formal parameter. So this function is called Factorio, which will be used to compute the factorials of numbers given, is supposed to receive one parameter. It's supposed to receive a value and store that value in the parameter called num, which is of type long. And at the end of the day, it's supposed to return a value which is of type long, to the caller. And then the statement for it to execute are as follows. If the content of the memory location called num, the local variable called num, if the content of the local variable called num, whatever is there is equals to 1, meaning if, for example, the value received is 1, then it means 1 is stored in the local variable called num. And therefore, if 1 is equals to 1, that is correct. Do what? Return 1. So return 1 to the caller. This means that the factorial of 1 is 1. That's true. Factorial of 1 is 1 because it is 1 times itself. Otherwise, if what is in the memory location called num is not equals to 1, then do the else part. So else, compute num or compute factorial. Compute factorial as follows. Pick that content of memory location called num. Whatever is there. For example, if what is there is 10, 10 is stored in num, then it means that this is how the factorial will be computed. The first round, it is 10, which is num, 10 times factorial of 10 minus 1. So that means it will be 10 times factorial of 9. So 9 becomes the new parameter for factorial. And then therefore, next it will be 9 times factorial of what? Factorial of 9 minus 1. 9 minus 1 is 8. So it means it will be, when the function factorial repeats, it will be a num times 9 or factorial of 9 minus 1, which will be 8. Then next round, it will be num, which in this case will be 8 times factorial of 8 minus 1. That is times factorial of 7. Factorial 7. Next round, it will then be num, that is 7, times factorial of 7 minus 1. Factorial of 6. So simply, what this function here means, or what this return statement here means, it is simply pick what you have received as content of num. Pick what you have received, store it in the memory location called num. Then multiply it, that content, to the factorial of what it contains, the content minus 1. So if you receive 10, it will be 10 times factorial of 10 minus 1. So it is 10 times factorial of 9. Factorial of 9. And that will continue. Factorial, the parameter for factorial will now be 9. Next round, it will be 9 minus 1. Next round, it will be 8 minus 1, all the way until the least value arrived at as factorial is, or until the least value of num will be 1. Until the least value of num will be 1. So that then at the end of the day, the factorial will be, if you enter 10, it will be 10 times 9 factorial. 9 factorial is the same as 10 times 9 times 8 factorial, all the way. So the final answer, the final product will be that num multiplied by num minus 1 times num minus 2 times num minus 3 times num minus 4, all the way. And then the final answer, the final product, will be returned to the calling statement, which is this call statement here. So Factorio, the function Factorio will now return a value, the answer. That answer or that value will be assigned into the memory location called answer. And then the next statement to be executed will be the Factorio of, if for example, we entered 10, that is what is the memory location called num, it will be the Factorio of 10 is, it will pick what is the memory location called answer and display. For example, the Factorio of 10 is, that figure will be displayed. And then the control B return back to the operating system through return 0, and the program will end. That is in C. In Pascal, it is also done in the same way. What changes is only the syntax. So in Pascal, I have the program called factorials. Then I am declaring two variables, num and the answer. And these ones are followed by a definition of a function called Factorio. It is having one parameter, num. So it means it will receive one value, and that value will be stored in the memory location called num. And this function is supposed to return the answer being of type integer. So once it receives a value for num, it will check the content of num. Is it equals to 1? If it is equals to 1, then 1 will be assigned to Factorio, to the function called Factorio, and be returned to the caller. But if the content of num is not equals to 1, then what it will do, it will pick that content of num. If it was 10, it will pick 10 times Factorio of 10 minus 1. So 10 times Factorio of 9. What will be gotten as the answer will be assigned back to the function called Factorio, and that will be returned back. So because this statement here, Factorio is a function which is calling itself within the function, or within itself, a function calling itself within itself as a statement, as an execution statement, it means that this function called Factorio will repeat computing and computing until the last value will be 1. That is, the value of num will be 1. So it will be, for example, if you enter the 10, it will be 10 times Factorio of 9, which is 9, times 8 Factorio. 8 Factorio is 8 times 7 Factorio all the way. So the value of num will continue decreasing until it becomes 1. And that is when the final answer of Factorio will be sent back. So it will be the product of num times num minus 1 Factorio times. So simply, let me put it this way. The final answer will be num times num minus 1 times num minus 2 times num minus 3 times num minus 4 times num minus 5 until the value of num is 1. So that product will be returned back to the calling function or the calling statement. And then it will be received here, and that value will be stored or assigned to the memory location called the answer. And then the next statement to be executed is, this statement will be displayed on the screen, the Factorio of num. Whatever is in num will be displayed here. So the Factorio of, if for example we enter 10, it will be the Factorio of 10 is. If for example we enter the 4, it will be the Factorio of 4 is what is value which was returned and stored in memory location called answer. It is the Factorio of 4. In that case, it will be 24. And therefore, right line will do the following. This statement will be executed to display the factorial of 4 is 24. Why? Because the memory location called num is holding 4. So 4 will be displayed where num is being written out. And the content of answer, memory location called answer is 24. So it will be displayed where answer is being written out. So the statement that will appear is the factorial of 4 is 24. The factorial of 5 is etc. And that is the end. Let's now look at another example of a recursive function that is for determining the end value in a Fibonacci series. Fibonacci series is a sequence of numbers which follows the following series: 0, 1, 1, 2, 3, 5, 8, 13, 21, 34, 55, 89. Each next value is gotten by adding 2 numbers before it. In other words, to get values in a Fibonacci series, what we do is simply we add the first 2 numbers. For example, if we add 0 plus 1, we get 1. Then 1 plus 1, we get 2. Then 1 plus 2 is 3. 2 plus 3 is 5. 2 plus 3 is 5. I repeat, the first 2 numbers in Fibonacci series is 0 and 1. So to get the next digit, you add the first 2, the previous 2. So 0 plus 1 gives you 1. Then to get the next number in the series, you add 1 plus 1. That is 2. So you get 2. Next, to get the next value, it is you add 1 plus 2. That gives you 3. To get the next digit in the series, you add the previous 2. So 2 plus 3, you get 5. To get the next value in the series, you add 3 plus 5, you get 8. To get the next number in the series, it is 5 plus 8, you get 13. To get the next value in the series is 8 plus 13. That gives you 21. To get the next value in the series, it is 13 plus 21. You get 34. To get the next value in the series, it is 21 plus 34. That gives you 55. To get the next value in the series, it is 34 plus 55. That gives you 89, etc. Therefore, my dear students and the rest of the learners, that's how we generate the end value in a Fibonacci series. So the next or new value depends on the values of the previous 2 terms. Therefore, to get end value, you compute it as x minus n minus 1 plus what is in the position for x minus n minus 2. In other words, to get a value, for example, for the value in a series, for in this case being n, then it is you get the value which is the immediate 1 value, that is n minus 1. In terms of position, these are position n, like to get position 5, the value at position 5, it is position 5 minus 1. So that is position 4 plus the value at position 3. So for example, to get 8th number in the series, the 8th number in the series, which in this case is 13, you add the 7th number in the series, which is 8 minus 1. That's the 7th number in the series. And in this case, it is 8. And the 6th number in the series, 6th number, that means 8 minus 2, 6, 60. So which is 5. So 5 plus 8, you get 13. So to get, for example, the 8th number in the series, you add the 7th number in the series plus the 6th number in the series. Now that the next value depends on the values of the previous two terms, that is called a recursive function. It's called a recursive function. The following is therefore a program in C determining the end value in a Fibonacci series using a recursive function called Fibonacci. My dear students and the rest of the learners, I would like you to copy this program in your computer or in your exercise book, then paste it or retype it in your editor for Pascal or for C, and then run it and see what will happen. So that's our pre-process directive. And then we have a function. Our function here is called Fibonacci. It is receiving one parameter of type long and is supposed to send back one value, or is supposed to send a value which is of type long to the main function. So that's a function prototype. This is what we are calling prototypes in my previous presentation. So we have the main function. We declare two variables of type long. One is called value, the other one is position. Then we request the user to enter a value. So you want to determine the value at which position in the series, which position. So we want to find out a value in a certain position as the user will enter. So the user is supposed to enter a position. That value will be rendered and stored in the memory location called position. Then that value for the position will be sent to the function called Fibonacci. The function called Fibonacci will compute that value for that position and return that value and assign it in the memory location called value. So where is that function? So once this statement is executed, this call statement is invoked, the processor will go and find out where the function called Fibonacci is, carrying the value for the position. So here is our function called Fibonacci. So the value which was being carried, the value which we carried from position, will be dropped into this parameter here called long. This formal parameter, this formal parameter called n. It will be dropped here. This function is supposed to return a value of type long, and then it will check is what is in the parameter called n equals to 0, or is it equals to 1? If it is equals to 0 or equals to 1, then return that value. Return is 0 or return 1. Then check again. If the content of memory location called n is not equals to 0, nor is it equals to 1, then do the following. To calculate the Fibonacci, the next value, get n, the content of n, subtract 1 from it. So if the position was 6, subtract 1 from 6. That will be 6 minus 1. That is 5. So return Fibonacci of 5 plus Fibonacci of 6 minus 2, 4. So Fibonacci of 5 plus Fibonacci of 4. That is if the value of n is 6. So if, for example, the value of n is 6, or the value stored in n is 6, then the recursive part for the return, it will compute as follows. Fibonacci of 6 minus 1, that is Fibonacci of 5 plus Fibonacci of 4. Fibonacci of 4. And finally, that value which will be generated, it will be returned back to the calling function. And that calling function is main. So that value will be assigned into the value memory. And then the next message to be displayed will be, or executed will be, this one, which will display the following on the screen. The value at position, if it was position 6, it will be the value at position 6 in the series is, so the content of memory location called position will be displayed between position and in, where there is percentage LD for double, for long, which is data type identifier for long. And then under the part for is percentage LD, that will pick the value stored in the memory location called value. Whatever is there, which is of type long, will be displayed at that position. And then the control will be taken back to the operating system through turn 0, and the program will end. So that's how we do it. Remember, this is a declaration statement for, we call it the prototype for a function which has been defined past the main, as you have seen here. So what about in Pascal? This is how we do it in Pascal. The logic is the same. The code is the one which is different. So my program is called Fibonacci. I have two variables, one called value, the other one position, they are of type integer. Then I have the function called Fibonacci. It has one parameter. I'm calling it n. This function will return one value of type integer. Then I have the begin. Check what is received as the value in n. Check what is received and stored in the memory location called n. A set equals to 0 or equal to 1. So is the content of memory location called n equals to 0 or equals to 1? If yes, if it is equals 0 equals to 1, return the value of n. That is return 0 or return 1. Otherwise, compute Fibonacci as follows. Fibonacci is, or compute Fibonacci as follows. Fibonacci of parameter. Value received minus 1 plus Fibonacci of value received minus 2. And remember, when I say value received, it is the position. So if, for example, you receive 6, and that 6 is stored in n, then in this case, it will be Fibonacci of 6 minus 1. That is Fibonacci of 5 plus Fibonacci of 6 minus 2. That is Fibonacci of 4. So Fibonacci of 5 plus Fibonacci of 4 will give you, or will give the result of the value at position 6 in the Fibonacci series. Then the overall result will be returned back to the calling of the main function or main program, where that value will be assigned to the memory location called value. And then next statement to be executed will be the value at position. If it was position 6, if 6 is what is stored in position, it will be read the value at position 6 in the series is what is stored in memory location called the value. So what is there will be picked and displayed. as a number there. And then the program will end. So with that, my dear students and the rest of the learners, we have come to the end of this session 4 of 4 in the topic on subprograms. You can now proceed and listen to the next part in the series. Congratulations for learning section 4 of 4 of the topic subprograms. You can also access section 1, 2, and 3 of this topic, other topics in the computer structured programming unit, as well as other computer or ICT videos by clicking or tapping on EMELISWAP ICT YouTube channel below this video. You can also visit EMELISWAP Life Skills YouTube channel for free life skills, motivational, and inspirational resources. To subscribe to the channel, tap on subscribe button below this video in YouTube if it's not currently reading as subscribed. For any further correspondence, kindly write it to us through the email emeliswap@gmail.com. Thank you very much for listening to me, and let's meet in the next part of the series, which is part 22. God bless.